Okay, more from 6.4. This is number 13. And this was kind of under the same auspices as number 11. So from number 11, we had this differential equation, y equals c, e to the kt. We derived that in number 11, so we can use that. And we have two bits of information. Y sub 0 equals 50. That means when t is 0, y equals 50. And then y of 5 equals 100. That means when t is 5, y is 100. So we've got two bits of information. We want to solve this because we're going to have to find c and k. So we have to kind of find both those. So two unknowns, we need two sets of information. Now this is really nice because I do have a real initial condition when t is 0. So if I put this information in my equation first, I'm going to be able to find the c. So y equals c e to the kt. So y is 50 when t is 0, and that's nice because that becomes 0. So this becomes c e to the 0. E to the 0 is 1, c times 1 is c. So 50 equals c, so that implies that 50 equals c. So I can put that back in this equation. Y equals 50 e to the kt. But now I have to find out what k is. Okay? Because we had two unknowns. All right. So y equals 50 e to the kt. But we also know that from the second bit of information up here, when t is 5, y is 100. So y is 100 when t is 5. So I put that in. So if I divide both sides by 50, I get 2 equals e to the 5k. Then I can take the natural log of both sides. So the natural log of 2 equals the natural log of e to the 5k. And then I can use the property logarithms and bring that 5k down in front. So natural log of 2 equals 5k, the natural log of e. But what's the natural log of e? Well, that's just 1. So that just equals 5k. So if the natural log of 2 equals 5k, if I divide both sides by 5, I get k. So k equals the natural log of 2 divided by 5. So I can put that back in my equation now. Okay, which is y equals 50 e to the kt. So y equals 50 e to the k, this is my k, the natural log of 2 over 5t. So that's my y equals 50 e to the kt. And I could also write it like this. This is a little bit easier than having one big fraction. So it's 50 e to the, and this is my k, but I could write it as 1/5 the natural log of 2 times t. So there's your final answer. Okay. I'll leave that for a second. And then number 15, it says in exercises 15 through 18, complete the table for an investment if interest is compounded continuously. All right, so let's take a look at number 15. And we have a table. And if interest is compounded continuously, we use this exponential form. A equals a sub 0 e to the RT. Now, sometimes you might have seen this as PERT, where amount equals principal times e to the r times t. So that's kind of where PERT came from. We actually derived this, so this is where PERT came from. But we'll just use the a sub 0 because that's what they're using in the book. So this is the doubling time, all right? Okay. So we want to see how long it takes for it to double. So if it's going to double, the ratio of the amount I have over the initial amount would be 2 to 1 because I doubled. I've got twice as much than what I started with, so I could just write this a over a sub 0 equals 2. And this is the doubling time at 8%, 8.6% interest. So it doesn't really matter what amount I've got. Just that ratio is going to be 2. All right? And even number 15, it was 1,000. We could have called this 1,000, and this 2,000. That would be 2 over 1. Okay, just simplify it. And then I just take the natural log of both sides. So the natural log of 2 equals the natural log of e times 0.086. That's my 8.6% in decimal form. 0.086t. And then I'll use my property logarithms to bring this in front. So I have 0.086t times the natural log of e, but the natural log of e, again, is just 1. So this natural log of 2 equals 0.086t. And then if I want to solve for t, I just divide both sides. So t equals the natural log of 2 over 0.086. Then if you work that out in your calculator, natural log of 2 divided by 0.086 is 8.06 years. Okay. Now we also had a b part. Well, we didn't have a b part. We had two different spaces in this table, and we wanted to see what was the amount we had in 30 years. And that's just with $1,000 invested at 8.6%, and it's compounded continuously. So again, we're going to use this PERT type. A equals a sub 0 e to the RT. All right? And it's just a straight formula. My initial amount of money was $1,000. It's given to me in the table. And this is my R is 0.086. That's 8.6%. And this is my T, which is 30 years. And then you just calculate this out. E caret and then 0.086 times 30. Enter, multiply by 1,000, you should get this. So hopefully that will be pretty much straightforward. Hope that helps.